So as we continue on in lesson 7.2, what do we do when we have four-term polynomials? What can we try to see if they are still factorable even though all four terms don't have a GCF? Maybe there's another way we can go about it and still be working with the GCF. So when there is a four-term polynomial, we're going to try to, in other words, not every one can we do it, but we are going to try to factor by grouping. We're going to attempt to see if it can be factored by grouping. So I am going to tell you that in your homework today, all of them will be factorable. You will be able to because you need the practice. But not all four-term polynomials can be factored, okay? So we're going to, when it says factor by grouping, we're going to make two groups of two terms each because 2 times 2, that would cover all of our four terms. So we have all four terms. 2 of them belong to one group, 2 belong to another, and then we're going to GCF each group. So it's kind of like they're going to work independent of each other for a little bit, and then they're going to come back together. So after we have GCF each group should have a common factor. So that when we GCF the first group, we're going to have a monomial times a binomial. When we factor GCF the second group, it's going to be a monomial times a binomial. That binomial factor in each of them can be common, or in other words, it can be a GCF now for the whole works. So here's an example. 6x to the 4th minus 4x to the 3rd plus 12x minus 8. Now, if you were going to do that before I taught you what I'm going to teach you today, you would probably say the GCF is what? 2. That's all you can do is take a 2 out, right? Okay, well, we can do better than that. Notice its factored name is right here. I want you to actually add that in your notes. This is its factored name. And notice 2 isn't one of the factors. Unless we pull it out of this last factor right here. It could be factored out of that, couldn't it? It could come out of that. Okay, so notice what I did in the first bullet underneath that. I have changed the subtractions, first of all, because it's imperative. It is really a big deal that you change subtraction to add the opposite in these types of problems, okay? It's going to save you a whole lot of headache. After you've, or it kind of in the same process when you're changing that subtraction to addition, that's what's happened here. Add the opposites. Put parentheses around 2 of the terms. Make a couple of groups. And now you look at that first group and you say, what is the GCF of 6x to the 4th plus negative 4x to the 3rd? And we're going to take out a 2x to the 3rd. And here's what the resulting factor is. So that's what you were doing for today and the day before, last week. This one, its GCF is 4. And the resulting factor is 3x plus a negative 2. And notice something about those binomial factors. They are exactly the same. So now that we have those two factors in common, these two groups have those two factors in common, now it's kind of like saying, okay, this is the GCF of the whole four-term polynomial. Both, it's kind of like we have two terms now, so here's what I'm going to point out. This is a term, the first group. This is a term, the second group. Each term has the factor 3x plus negative 2, so I've put that right here, but I just cleaned it up to 3x minus 2. This is now the GCF of the whole works. When we divide that 3x plus negative 2 or 3x minus 2 out of each group, after we take it out of this one, we have the 2x cubed left. After we take it out of this one, we have the 4 left, and we have that plus sign. Find somewhere off to the side over here, and would you multiply this back out? Would you FOIL it, rectangle it, whatever works best for you? Come over here to the side, I want you to multiply that and verify, because maybe you're not convinced that's a factored name for it. Multiply it out. Take 3x plus negative 2, I'm going to unclean it up again, times 2x cubed plus 4, and see what happens. Rectangle it, FOIL it, distribute it, whatever you do. Anybody get it to go back to its other name?
Yeah.
Those of you are still working on it. Today in your homework, you are going to have to do check problems. You are going to have to make sure your answer does multiply back to the original 4-term polynomial. So today, yes, we will do check problems. Okay, I got a couple of guys who said it did. Anybody else? Yeah, okay. A few others? Okay, then we're feeling pretty confident that that's a good factor name for it. Okay, let's practice. I think we have 3 of them to practice. But this one I put up on the board here being our last one. Okay, number 1. 6a to the 3rd plus 8a to the 2nd plus 9a plus 12. Well, it's already addition, so we don't have to change any subtraction. Let's make our groups. Let's just take those first 2 and group them together. This plus sign right here, in the middle of everything, is the plus sign between the groups. So make your 2 groups, and now what you do is you GCF each group independent of each other. They each have their own GCF. So what would so today is the day that I'm hoping that after a couple of days of practice, we can look at those 2 terms, 6a to the 3rd, and that 8a squared, and say, what is the GCF of those terms? So what do you think, Devin?
4a squared.
4a squared? Do you guys agree with that? 2a squared? Yeah, 4 wouldn't go into 6, would it? Okay, so 2, because 2 is the largest numerical part that goes into 6 and 8, and the most a's we have is 2 of them. So we have 6 divided by 2 is 63, and a cubed divided by a squared is a. And if you're not ready to do this without showing work, without showing all that, prime factorization like we were doing, the dividing, by all means do it, okay? It's nice when we get to this point that we can just say, okay, this is the GCF, this is what I'll have after I divide each term by it. What's 8a squared divided by 2a squared, class? 4. Okay? Anything we should talk about there? Okay, so again, remember we always want to look though, and we want to make sure that after we've done the GCF, there isn't any more that could have been divided out. Is there anything that could be divided out of 3 that could also be divided out of 4? No. 3a that could be divided out of 4? No. So let's bring our plus sign down between the groups. What's the GCF of the next group? 3. No a's, right?
No.
No, because the second term doesn't have any. Okay, so 9a divided by 3 is?
3a.
3a. 12 divided by 3 is? 4. Questions? This is probably, oftentimes when we have these longer polynomials like this, when we have even numbered polynomials, this factoring by grouping is an essential skill. So notice something about our 2, we now are down to 2 terms. We have 2 groups that we made into 2 terms that are a monomial times a binomial. The goal is that these binomial factors are exactly alike, are they?
Yeah.
Yeah, they both are 3a plus 4, aren't they? So that means 3a plus 4 is the what? GCF of the whole works, yes. It becomes the GCF. So we have now the binomial 3a plus 4. So today, instead of in the end having a monomial GCF, you will have a binomial GCF. Because remember, a binomial times a binomial typically gives us either a trinomial or a four-term, I guess it can give us a binomial or a trinomial or a four-term polynomial. And then what would our other factor be? Now we don't bring this plus sign down. This is where students have the hardest time recognizing what you should do here. This plus sign does not come down between the factors, okay? This plus sign is going to be in this next factor. So we have the 2a squared left, plus that 3. There's its factored name. Okay, now we're going to multiply it back out and make sure. Okay, so go ahead and use the method of your choice. And don't be looking at the original name while you're multiplying. Actually do the multiplying out. And then see what you can do. I don't see any like terms. But I do believe this one started out in standard form, so I'm going to put mine in standard form and see if it matches. I got it, did you? Yeah. Okay, so again, you have to do a check problem. And a check problem is not this. This is not a check problem. I want to see something more than this written down, and then this. Because I'm really going to be disappointed if it is especially what you have there truly does not multiply out to what you put there.
You're saying you can use FOIL.
Use FOIL, use the rectangle method, use distributive property, but show the four multiplications, okay? Do not leave the four multiplications in your rectangle though, or in your FOIL, and not bring them all together like I did right here. Eventually I said, here is my polynomial. Now I'm going to go back and say, does it match the polynomial that we started with? And it does. 6a cubed plus 8a squared plus 9a plus 12. Questions? Do you think this is okay? Was it important to learn how to GCF? Yeah? Okay. Let's go to the back side then. Now, this one's not in standard form to start with, and I just want you to know that it's okay if it's not in standard form. It doesn't mean you still can't factor it, but you may put it in standard form if you would rather to do the factoring, if you like it better that way, okay? So it does not matter if you do it like this. No, you should still be able to do it. What we want to do, though, is we want to change those subtractions to add the opposite while we're making our groups. So again, this addition in the middle, and you always want addition in the middle. If you don't have addition in the middle, that's where you're going to get yourself in trouble. Okay? So addition, and then 9 plus a negative 3x. So probably the most important subtraction is if it falls in between the second and the third term. Because if you just insert parentheses, then you are now saying you're going to make both of those things in the group their opposite. Okay? Okay, go ahead and GCF each group. See what you get for a GCF for each group. Okay, just check to see if you did something that my guy did, or did you do something else, or? Did you do the same? Did you have the same GCS for each group? Yeah? Okay. Well, are they good ones? Or in other words, if I had these guys trade places, in fact, I'll just do that right now. If I had these guys trade places so that the x was first, like it is in the other binomial factor, are those binomials matching? They're not, are they? So we cannot move on right now. We can't say, okay, well, I got this GCF, it's x plus negative 3. Or wait, no, maybe it's negative x plus 3. I'll just pick one of the two.
Could you change the GCF of the first one to a negative and then change that x from negative x to positive?
You could, but the more sensible thing to do is let's do it to the second group instead. Let's make the second group's GCF negative. Okay, I thought you said the first one. Okay, so what we'll do is instead we'll say, let's make the second group's GCF negative 3 instead of positive 3. And then when we take 9, well, like now that we got to turn around, we'll do the negative 3x first. When we take negative 3x divided by negative 3, we're going to get a positive x, aren't we? And when we take 9 divided by negative 3, we're going to get a negative 3. And now they match, don't they? So that's huge. Don't even move on at this point if you do not have matching binomial factors right here. They have to be exactly the same because they become, remember, the GCF of the whole group. So this is going to, instead of x plus negative 3, we'll make it x minus 3. GCF of each group comes out. We divide it out. What's left from the first group? 2x squared. What's left from the second group? Plus a negative 3. Or in other words, we can clean that up also. 2x squared minus 3. This is what we believe the factored name is. And now we do a check problem, okay? And I'm counting on that you're all doing it. You will not get your paper stamped tomorrow without it. And remember, this is not, I'm going to do the rectangle because this is typically what I see. See, that is not what I meant to do. This is typically what I see on papers when they come back tomorrow. That's as far as some students might take it. Am I going to accept that? It's not enough, is it? Now I need to bring all of those things out of the rectangle. And if I remember right, this one wasn't in standard form, and you guys said it's, let's do it without putting it in standard form. So the 9 and the negative 3x need to trade places. So let's see if I have those guys trade places. This will be a plus 9 minus 3x. And now it matches, doesn't it? So do you see what would have happened if we would have put it in standard form to start with? What would that have saved us? It would have been in the order the other one was in, wouldn't it? So sometimes it's worth it just to put it into standard form to start with. Okay. Questions? Okay, let's do the one that I had up here on the board that I actually had put into standard form, and they did not have it in standard form. Okay? So Should we work it the way it is? Oh, you know what, we are gonna work it the way it is, because I like the fact that this one has that subtraction in the middle, and I wanna point out what's gonna happen to you if you don't do something about that. If you decide to ignore me and just stick in parentheses, what did you just do?
Change the entire, like, second one to, so it'll be
Okay.
negative 4y.
So when I give this subtraction, remember in subtraction of polynomials, we just made this into a subtraction of polynomials, did we not? We have a binomial minus another binomial. So we just made it into a subtraction. When we subtract, that means all terms have to be subtracted. So this subtraction would be given to that 8. This subtraction would also have to be given to that 4y squared. Was it minus 4y squared in the beginning? No. So this is a big deal that you do not do what I just did right there in green. Instead, you change those subtractions to add the opposite, and the only thing that got changed to its opposite would have been the 8, not the 4y squared. Make sense? Okay, now go after this. The one you said that you could not factor. Show me otherwise now, because you can factor this. Let's have a little talk about how we should know when we should make that second group's GCF negative or not. You know, because you're going to have to make that decision every now and then. Why, especially since this was a negative 8 here, why didn't I make that a negative 4?
Because the left one's a negative 2, so you don't keep it right.
Yeah, I wanted, this one has a negative 2 in it, so I'm like, oh, wait a minute, I need a negative 2 when I divide by that GCF. So if I would divide by a negative 4, I would get a positive 2. So you're going to have to do some, you know, like critical thinking there, like what should I do? And if, let's say you had taken out a negative 4, and this is what you got instead, whenever these guys are opposites, both of them are opposites of each other, you know that all you got to do to fix that is go out here and change the sign on your GCF, okay? So we're not going to really do what I was doing here. We're going to make this, okay. And now, can these two trade places?
Yeah.
Yep. So we're going to say our GCF is what?
Y2 minus 2.
Y what?
Squared.
Y squared minus 2.
Yeah.
And the other, do not put a plus sign between these parentheses. The groups are no longer groups anymore. They are back together. We're back to having a polynomial that's working, everything's working together now. So no plus sign between these groups. There are times I have to take a point away from the answer because there's a plus sign between those parentheses. And 4 plus 2 does not mean the same as 4 times 2. So, what's the other factor?
Y plus 4.
Y, okay, the one that's left out here, and plus 4, the one that's left out there. Y plus 4, okay? Do your multiplication problem. This is our answer, we say. And now we multiply it out. In other words, do a check problem. And let's see, if I remember right, this wasn't in standard form. Oh, goodness sakes, so the y's and the constant are in the middle. So you guys need to come over to the middle. And that guy needs to come to the middle and you move to the end, okay. I'm getting there, how about you?
Yeah.
Did yours check out?
Yeah.
Let's see, mine look exactly like it. Y to the third. Mine, I'm gonna minus 2y minus 8 plus 4y squared. Success. Okay, so this time I did the distributive property method. I did all three ways of checking this time. I did this. So my four multiplications that way. Here's one of them, two of them, three of them. What did I not? Oh, I didn't show my multiplication up there. Is this a harder way? It's sometimes a little more confusing. It's really FOIL, just not written out FOIL. It's really what it is. Okay? So, questions? Can you do this?
Yeah.
Okay, you got 15 minutes to get a good start. Let's go.